All right, we're on our last lesson for term 3. So 9.4, factoring quadratic binomials. What? So again, binomials means we have two terms. Here's a binomial, here's a binomial, okay? So, but remember, before we get any further, let's make sure we remember what standard form is. That's our ax squared plus bx plus c. So for the last few lessons, we've been focusing on quadratic trinomials, which means we have three terms. But today we're going to focus on factoring quadratic binomials that have two terms. All right, so here's two examples of quadratic binomials. I want you to look at those and compare them. Compare and contrast. What do you notice that's different about them? Okay, so if you want to pause and think about that for a minute, you can. But if you notice, for this first example, if we look at like the standard form, the bx is missing. So here, bx is missing, okay? Whereas the other is where we're missing c, the constant, okay? And we'll treat those a little different, all right? So let's see if we can do this problem together. Again, if we're going to factor a quadratic, we need to somehow come up with what we did is we did glasses, right? So we would start by doing glasses. Again, we do the x squared term and the constant. So that ends up giving us a negative 9x squared. And we need to find two things that multiply to give us that and add to give us the middle term. But where did the middle term go? Okay, for it to disappear, what does b need to be? Well, b would have to be 0. So it'd be like, you could write this as x squared plus 0x minus 9. Okay, but 0 times x is just 0, and we don't want to write down a 0. Okay, we want to simplify it. So now we have those two things that multiply and add. Or we need to now, sorry. So again, we can write down factor pairs. We could do 9, could be 1 and 9. But there's no way we could use 1 and 9 to get to 0. The other would be 3 and 3. And that could work, right? So if we did 3x minus 3x, those would cancel out, and we would end up getting 0x. So then we could take that negative 9, we could take that and substitute that in for the middle term, for that 0x, and we'd have x squared plus 3x minus 3x minus 9. Okay, we can cut that in half. We could take out an x. That leaves us with an x plus 3. And on the other side, we could take out a negative 3. And that leaves us with x plus 3. So we end up getting x plus 3 from those two parentheses that we could factor out, and what's left gives us an x minus 3. All right, again, you can do the same thing with the box method. You could take those four terms and we could do an x squared and a 3x and a negative 3x and a negative 9. And here we could factor out an x and a negative 3. And then from the columns, we could do an x and a positive 3. Okay, but the same thing. Okay, so let's look at these, do some more, do a couple more of them, and see if you come up with a pattern. Okay, so here if we did the same thing, we want to multiply those together. That gives us a negative 25x squared and adds up to give us that middle term, which is a 0x. So if we wrote down factor pairs for 25, we could do 1 and 25 or 5 and 5. So to end up getting 0, this is basically telling us that they are 0 apart. The numbers have to be the same. So 5x minus 5x. And then we could use, I don't know, let's do the box method this time. So we have our x squared. I guess we could rewrite this thing as x squared plus 5x minus 5x minus 25. So 5x, negative 5x, and a negative 25. So we could factor out each row and column, take out an x, take out a negative 5, take out an x, and take out a positive 5. So our answer will be x plus 5 and x minus 5. So maybe you're starting to see a pattern. For just the sake of the video, we're going to talk about those. So if you notice that when you have the middle term is missing, sorry, excuse me. If you're missing the middle term, it looks like the two numbers that go inside those parentheses are just the square root of that term, okay? So if that makes sense, then kind of use that. If not, it's okay to just do the same thing that we've always done, okay? What should you look for when you factor? Again, it's the greatest common factor. Here's some other examples that you could try. Some of them have greatest common factors that you need to take out first, or else it's not going to work out very well. Okay, so for example, B, what would be the greatest common factor? Well, it looks like we could take out a 3. So that leaves us with an x squared minus 4. And then we could do the same thing we've done before. So again, this is like an x squared plus 0x minus 4. We could do our glasses. Negative 4x squared needs to add up to give us 0x. Okay, again, the things that will make that work is they have to be the same. So 2x minus 2x gives us 0x, and if we multiply them, it gives us the negative 4x. Okay, so then we could do, maybe I'll do grouping this time, so we need to plug that into the middle term. So plus 2x minus 2x minus 12. We'll cut that in half and we'll just factor it up. So take out a 3 and an x. Nope, can't take out a 3, sorry. Tricked ya. Oh, and I'm sorry too. Knew I was going to do this. Okay, so here, say, Mr. Warner, you did a bad choice. Okay, we need to plug it in. We need to plug this in for this equation after we take out the greatest common factor. So we'd have x squared plus 2x minus 2x minus 4. Then we can do our grouping. So we can take out an x. That leaves us with an x plus 2. That's a fat marker. Here we could take out a negative 2. That leaves us with an x plus 2. So again, those are the same, so we can factor those out in the front. So that's x plus 2. And then what's, I guess that's probably a little confusing. Let's just factor it out in over here. So that would be x plus 2. And then what's left would be the x minus 2. All right. Oh, but wait, Mr. Warner, you took out a greatest common factor. At the beginning, that means we need to include that. So it should be 3. So again, you should always be able to distribute everything back and get the original problem. Okay. Let's do one more together. So does D have a greatest common factor? You bet it does. Let's take out that negative 1. Okay. If you don't, then it won't work out. So make sure you do that. All right. So again, we need to do our glasses. Two things that multiply to give us negative 16x squared. And adds up to give us that middle term, which is 0x. Okay. Hopefully you're starting to get this, that all you need to do is, it's like the square root of 16. So the two things that multiply to give you 16 and add up to give you 0 has to be 4x minus 4x. So we would plug that in for the middle term. We get x squared plus 4x minus 4x minus 16. And this time I'm going to use the box method. So x squared 4x minus 16. Looks like we could take out an x and a negative 4 and an x and a positive 4. So we would have x plus 4. Don't forget the greatest common factor that we took out. And then x minus 4. Alright, so that is factoring out quadratic binomials when the middle term is missing. Okay, again, if you're interested to do more examples, let me know and I could do some in a second video. Alright, what about if the constant is missing? Again, what should we always check? First is the greatest common factor. So what is the greatest common factor for those two terms? Can we take anything out? Well, we sure could. There is an x in both of these terms, so that means we could factor that out and we get x minus 9. And what do you know? Bam. We're done. Okay, we can't factor. There's not any x squareds. So if there's no exponents, then it's fully factored. Okay, there's nothing we can pull out of that parenthesis. So sometimes we don't have two parentheses, and that would always be the case when there's not a constant, or the constant is 0. So give these a couple try. Pause it and give it a try. Again, always look for the greatest common factor. Looks like we could take out an x. What we have left is x minus 2. Bam. What about this one? Looks like we could take out an x. What's left? X plus 1. Okay, again, if you're doing x divided by x, we still always have like a coefficient, whether it's be a 1 or not. So don't forget that. Here, leading negative. Let's take that negative out. So, and an x, a negative x. So divide everything by a negative x, and that leaves us with a positive x and a negative 4. And then for C, looks like we could take out a 3x. That would leave us with, the 3's would cancel, and we take out one of those x's, so we just get x, and we get plus 2, and the x's would cancel. Alright, so that is that. I think on your homework, if I recall, there are some other ones that you can review. So I did a bunch of the binomials, and then I have a couple review that I would like you to do that too, so you don't get rusty. Okay? Alright, we'll see you later.